All right. In this video, we're going to be looking at function composition. What is the composition of two functions? So, brand new operation. We talked in the last video about how to add two functions or multiply two functions. Today, we'll talk about how to compose two functions. So, given f of x and g of x, if f of x is composed with g of x, we have the following statement. We could say f open circle g of x. This open circle is the symbol for function composition, just like this is the symbol for addition, or this is the symbol for division. That open circle is the symbol for function composition. It is not multiplication, so be careful. So if you see f circle g of x, it means f of g of x. It means to take g of x and plug it into f of x. And we're going to see several concrete examples of this. But these two mean the same thing. F of g of x and f circle g of x both mean the composition of f and g. Okay, so let's jump right into some concrete examples. Let's look at number 1 here. It says f circle g of x, where they give us a bunch of different functions. So they each have their own names, f, g, h, and s. In this first example, they want us to find f of g of x. F circle g of x, which we've just talked about, means f of g of x. Okay, f of g of x. It means to take the inside function and plug it into the outside function. Okay, so let's do that maybe slowly for the first example, and then we'll pick up the pace. Let's let g be the function here in red, and let's let f be the function here in blue. Then to find f of g of x is to find f of g of x, but g of x is just x plus 1. So this is f of x plus 1. Right? Originally we were asked to find f of g of x in this step, but we realized that g of x was really just x plus 1. So I replaced the g of x with x plus 1. Okay, and then now we're charged with finding f of x plus 1. What on earth could that be? So let's try and remember. Remember, to find f of, like, 2, we took whatever was inside the parentheses and we plugged it in for x. That's how you find f of something. You take whatever's in the parentheses and you plug it in for x. So that's exactly what we're going to do here, but what's in the parentheses isn't a number, but it's still true that we can take whatever's inside the parentheses and plug it in for x. Okay? Although in this case it won't be x squared, it will be x plus 1 squared. Right? We took g of x and plugged it into f of x. We took x plus 1 and plugged it into f of x. That's how we got x plus 1 squared. Okay? That's what function composition asks you to do. It asks you to take the inside function, in this case g of x, and plug it into the outside function, in this case f of x, to get a final problem. Okay, so now the rest of the problem is just going through the algebra to simplify this. So now we're down to here. What is x plus 1 squared? Well, please remember that x plus 1 squared is x plus 1 times itself. Right? That's what it means to square a number. When I ask you to square something, I want you to take that thing and multiply it by itself. So x plus 1 squared is x plus 1 times x plus 1. And so now we can FOIL this and be done. So first would be x squared. Outer would be x times 1, so plus x. Inner would be 1 times x, so plus another x. And then last would be 1 times 1, or 1. Giving us a final answer of, when we combine like terms, x squared plus 2x plus 1. This is f circle g of x, or f of g of x. Awesome. Okay. So that's that problem. So let's look at example 2. H circle g of x. So again, the hardest part for some of us will just be realizing what this is even asking. It's not asking multiplication, because it's an open circle. It wants us to find h of g of x, just reading in order. H of g of x. So that's, remember, we're going to take the inside function, g of x, and plug it into the outside function. So let's look at what that's going to look like. Again, if we want to use some color, let's let g of x be the red function. Let's let h of x be maybe green. So we're going to take g of x, this guy here in red, and plug it into h of x. So let's see what that's going to look like. That's going to be h of g of x. That's h of x plus 1. That's what this was, x plus 1. So we're going to take this x plus 1 and we're going to plug it in to the h function. Take this x plus 1 and plug it into the h function, giving us what as a result? Well, it's normally negative 4 times something minus 2. That's the h function. But again, we're taking what's inside the parentheses, this x plus 1, and we're plugging it in for x. So we're going to get this. Okay. We took the inside function, g of x, plugged it into h of x, so we get here. And then now that we're here, simplify. Negative 4x minus 4 minus 2. It's going to be negative 4x minus 6 when you combine like terms. Okay. Awesome. Let's look at example 3. S of g of 2. Whoa, S of g of 2. What on earth is that? Well, just like earlier, we're going to work inside out. So we're going to start by figuring out the inside piece. So I'm going to look at g of x. And then we'll worry later about the outside piece, s of x. Let's not do that. Let's do like purple or something. Get a little bit different of a color. Okay, so here we go. S of g of 2. So we're going to start on the inside, and we're just going to worry about what on earth g of 2 is. Once I find g of 2, I'm going to plug that number into the s function and then keep going. Okay? So for now, let's just focus on g of 2. Now remember, g of 2 is just what you get when you plug in a 2. So what's 2 plus 1? That's 3. So we've just shown that g of 2 is really 3. Right? G of 2 is 3. Okay, so now let's shift our focus, and now that we've found the inside piece, now let's look, what's s of 3? S of 3. Well, to find s of 3, we're going to plug in a 3 into the s function. So that's going to be negative 2 times 3 squared plus 3 times 3 minus 1. Plugging in a 3 in for every x that we see. And then going from here, that's negative 2 times 9, 3 squared, plus 3 times 3 is 9 minus 1. That's how I got the 9 and then the minus 1. So that's negative 18 plus 9 minus 1, which is negative 18 plus 9 minus 1. That's going to be negative 10. Negative 10. So to find s of g of 2, first start on the inside to find an answer to g of 2. We did, and we got 3. Then we looked at s of that answer and got negative 10 as a final answer. Okay. A few more here. What's h of f of x? H of f of x. H of f of x is h, well, sorry. H of f of x, h of x squared. Okay. To find h of x squared, you're taking whatever's in the parentheses and you're plugging it in for h. So negative 4x squared minus 2. Right? I replaced every x in the h equation with x squared. And we're done. Pretty easy problem there. Right. Take the inside function f of x, plug it into h of x to get out a final composition of two functions. Okay. Last two here. G of f of 1, g of f of negative 1, sorry. G of f of negative 1. So we'll first start by finding f of negative 1. We're going to get an answer to that, and then we're going to find g of that answer. So it's kind of like a nested problem. So let's find f of negative 1. So f of negative 1 is negative 1 squared, or 1. Awesome. Okay, now let's kind of double up on the problem. Now let's find g of 1. G of 1 is 1 plus 1, or 2. 2 as a final answer. Awesome. Last one here. Let's find g of h of 0. G of h of 0. So just like earlier, to find g of h of 0, work inside out. So find the answer to the inside problem. You're going to get a number answer. And then we're going to find g of that answer. So it's kind of a two-step process. First, let's start by finding h of 0 in the middle there. H of 0, that's negative 4 times 0 minus 2. What on earth is negative 4 times 0 minus 2? Well, that's just 0, so it's negative 2. Okay. Then now what's g of negative 2 to get a final answer here? G of negative 2 is negative 2 plus 1, which is negative 1. Awesome. So that's composition of functions, taking the inside answer and plugging it into the outside piece in general. Awesome. So in our next video, we're going to be looking at compositions of functions graphically, and then we'll be done. We're not going to worry about this problem for today.